Greetings viewers, I'm the Smithy9999 and welcome to Universe Sandbox 2. This is the upcoming sequel to Universe Sandbox, a game I have not done a video about, but you have seen it as I have used it for Beauty in Science. Link will be somewhere on the screen up there, maybe down there. Not up there, that would be off the screen. But I've also used it for my original intros for Gaming with Mates and Take on Mars, not Taking on Mars. I'll probably show a clip of that as well. But I also used it for creating my channel banner thing, header, whatever it's called, that picture thing on my channel page. Now, the original Universe Sandbox was very, very fun to play around with. It's a good physics simulation, not 100% accurate, of course. No simulation is, but it's also not a very strong simulation. There are plenty of better physics simulators out there available, but it is very user-friendly and fun to use if you don't actually understand most physics, and it's a good learning tool. So this is Alpha 12.1, as you can see on the bottom of the screen, hopefully, if it's recorded right. You can access this by purchasing through the website, link in the description. It goes through the Humble Bundle store, so yes, you go through that. It's $24.99 US to get into the alpha, and pre-order. It also counts as a pre-order for the full game due out summer next year on Steam. When you purchase it, you get a link, and it links it to your Steam account, which I'm guessing most people would have. And nowadays, most gamers. But if you don't, Steam itself is free. Now, some of the new features in this, apart from the very gorgeous, very, very gorgeous new graphics, let's turn down the simulation time to roughly half an hour per second. I mean, just look at the beautiful graphics of the sun. You can see the bubbling plasma surface of the sun itself, and also beautiful sound effects for the sun. This game also adds sunspots are apparently a feature, but solar flares have been added to the simulation, as well as climate simulation for planets. So let's just switch over to the Earth. Boom. Here we are. Yeah, so you can change around with different parts of the atmospheres of planets. There's also a procedural generation in this game now, and you can create random gas giants, exoplanets, and rocky planets, and you can change the materials that make them out of the hydrogen percentage, silicate percentage, water percentage, iron percentage, organic percentage, and carbon dioxide, and watch how they change, as well as distances from the start. So let's just, if we switch to hide rotation on, you can see the cloud structure of the Earth. Not a very accurate, I don't believe, simulation of cloud structure. It's not actually changing, they're just rotating, but it does show the different regions of the Earth's atmosphere rotating differently. But you can watch as the seasons pass and snow cover increases, which increases the albedo of the planet. You can get a lot of information on all the different planets. Like you can see here, we've got the temperature, average surface temperature of the Earth, which is currently 14.5 degrees Celsius. The mass of the atmosphere, which you can change, currently at 5.1 times 10 to the 18 kilograms. So that's 5.1 with 18 zeros after it. The average surface pressure of the atmosphere here at 98.1 kilopascals. That's lower than the one I use in calculations, which is typically use the hectopascals, HPA, not kPa. The scale height of the atmosphere, which I can't remember the definition of off the top of my head, embarrassingly. I only just did a course on atmospheric physics, and scale height is a fairly important feature. Yeah, that'll be written in below my face to make me look stupid. You can also change the albedo of the Earth, which is the amount, well, it's not exactly the reflectivity of the Earth, I don't believe, but the higher the albedo, the more light gets reflected off the surface. Yeah, so a high albedo planet. So a planet made of purely ice, for example, would have a very high albedo. Something which absorbs the light, lower albedo. So clouds have a high albedo which reflects light off. Ooh, you can look at the pretty snow in the Andes. Don't get distracted, don't get distracted. But you've also got stuff like the greenhouse effect, the temperature difference caused by the greenhouse effect. The obliquity and argument of the obliquity for the axis of rotation of the planet. The angle between rotation axis and orbital plane. So, yes, hang on. The orbital plane is, you can see the orbit here. The accuracy is not, well, that's why you see it's very janky. You can change the accuracy of simulation, but with this slider here, which of course slows the time because it's much easier to get an accurate representation without going too fast, because it allows the computer time to calculate the differential equations which determine the orbit. But this circle, which is a flat plane, as you can see here, I can't get it accurate because the Earth has a slight inclination on that axis, but there is a flat plane axis around the Sun, not perfectly like this. Yes, but the angle of the word I can't pronounce, obliquity, is the angle between that plane and the axis on which the Earth rotates, like that, because the Earth spins as well as orbits the plane. But you can also have a look at, well, the default simulation has all the accurate information, but you can play around with this sort of stuff. You've got the semi-major axis as the Earth orbits the Sun. It's not a perfect circle. It's a what's that? What are those things called? The non-perfect circle thing. I can't remember what the damn thing's called. But instead of having just a radius of the circle has a radius, these have two. You've got the semi-major axis, which is the largest distance between the center, between the object and its outer point, which it orbits around. So in that one, ellipse. That's it. The ellipse from the point where the object is orbiting, which is partway the center of the Sun, not the exact center. But yes, that distance is the semi-major axis. You can also change the eccentricity, which is a measure of... Ooh. Ooh. Imagine if the Earth could do that. But... Well, I killed it. I just killed all of life on Earth. Let's just switch to Mars for now. You can also hide rotation. You can also change the inclination between orbital plane and reference plane. the argument of periapsis, right ascension, mean anomaly. But you're also changing these. You can see the distance of the apoapsis and periapsis. Anyone who's played Kerbal Space Program will love those. As well as the orbital period. As you can see here, Mars has an orbital period of 1.88 Earth years. And here are the basic, very basic composition of Mars. Predominant 90% silicate, 10% iron, very little hydrogen, water, organics, and carbon dioxide. With the mass 8.73 times the Moon's mass. Its radius, density, and average surface temperature in kelvins, which is the scientific scientific unit of temperature measurement, rather than degrees Celsius or Fahrenheit, where 0 Kelvin is absolute zero, the lowest temperature anything can become, physically become. As you can see, we have here the whole solar system, including dwarf planets like Sedna, Eris, as well as a whole heap of asteroids. Although not asteroids, I think that, well, there's an asteroid. But you can also change the ambient background. So we can just set it to, you can set it so you got a bit of a nebula. This one's called Saturn Neptune, which I believe is just using colors, but you can also change, because it's procedurally generated backgrounds which have a random number generator seed which you can change. But let's play around here. Let's move Mars to a yes, basic. Let's change its semi-major axis to 0.99 AU. AU is an astronomical unit, where 1 AU is the distance from the Earth, the average distance from the Earth to the Sun. What was it? The distance from the furthest point? One of those two. But yeah, typical unit of measurement when you're talking about solar. Not solar. When you're talking about long distance, when you're talking about astronomical distances, you've got astronomical units for smaller distances. I say smaller, but that's for planets from stars and whatnot. Light years, which is the distance it takes for light to travel in a year, obviously, and of course parsecs, which is related to the parallax, a very inaccurate method of measurement, but incredibly useful for large-scale distances. But now, if we just leave this, we can go to, whoops, if we just pause the simulation, we can go to the really fun part of the universe sandbox, and that is creating your own simulation. You have a whole heap of things here. You can plant moons, including random moons, but also known moons like the moon, our moon. You also have the planets. You can have, as I mentioned earlier, you can have a random rocky planet, a random gas giant, and a random exoplanet. These two have randomized names, whereas the random exoplanets use random names based on exoplanets. And I believe it's probably just part of a database with all the information we know about exoplanets. But you've also got the 8 planets of our solar system. Hang on. Yeah, that's 8. You also have stars. No random stars at the moment, but remember, this is just enough. They might be able to, or you might be able to create your own using by compiling them. But you've got the Sun, Proxima Centauri, Barnard's Star, Wolf 359 for all you Star Trek fans out there. So yeah. You can also place galaxies, so you've got the large and small Magellanic Clouds, which are satellite galaxies to the Milky Way. They orbit around the Milky Way and pass through. You also have Andromeda, our neighbour galaxy. Pinwheel Galaxy, the M32, Cigar Galaxy, and Messier 085. Oh, no Milky Way this year. In this version this year. But it's pretty similar to Andromeda. There's also black holes, as this does a bit more. It's a bit more realistic with its depiction of black holes, with them bending light and whatnot. So you've got Sagittarius A star, which is the supermassive black hole that we believe is at the center of our galaxy, or galaxies believed to have a supermassive black hole at the center, and Sagittarius A star is the one believed to be at the center of the Earth. Look it up, I suggest. You can find videos of the evidence of the existence of such a massive object at the center of our galaxy based on observations of stars at the galactic center. But you also have a black hole which of 1 times the mass of the sun. So if the sun became a black hole, which unlike what if it suddenly became a black hole, it wouldn't. I'll show you that actually. I'll try that out. One with 100 times the mass of the sun, black hole, which is 10,000, 1 million, 10 million sizes of black hole. We also have minor planets, as they're called here, like Pluto, that one, Ceres, Sedna, Eris, Mate. You can also play pool, or bowling. Apparently that, of course, you've got a, okay, what's the word? What's in the film? 2001: A Space Odyssey. You've got the monolith from that, which you can send flying at Earth. User objects, so there's obviously some mod sport, and of course rings. You can put some rings around planets. So let us create our own solar system, shall we? Well, let's start with, well, we'll look at yellow stars similar to our sun, as they tend to be the right mass for planet formation. These blue stars you see here have very high masses and take up, from the creation of a star, they take up so much matter to the stars form from so much matter. There's none left for planet formation. So any planets found circling blue giants would be extrasolar captures, which can happen after a planet is blown out by supernovae or other cataclysmic events in in solar systems, sending planets just careening through space without a star to orbit, but they can be captured in the gravity wells of large stars. Let's start with Aldebaran. It's only 1.7 times the mass of the sun. Bright. Now, a cool feature of this is if we just go to simulation view, you can have the habitable zones of the stars viewed. You can view in a flat plane-like feature, such as here. So you can see this green area is where life can be formed around a star. The red area is where it's too hot, blue too cold, as you'd expect, which is really weird considering a blue flame is hotter than a red flame. But you can also have it as a billboard, so it's just, no matter which way you look, it's there as a flat plane. Or a cross, which shows all 3 dimensions, the habitable zones, in possible orbits. Let's just have it as a flat plane for now. Now, how about we add a planet? So, we'll go for a random rocky planet. We'll put it in the habitable zone of Aldebaran. Our planet named Tural. Whoa. I might just turn that off. Now that we've got... yes, stealth layers are on. Let's just set that. 5.5 hours. You can change the gravity factor of, so you can have a gravity universe which has a gravity factor higher than 1, which is 1 represents our universe. You can also change a whole heap of features like the collision data, not data, ways, how it does. You can have your volatile trails from stellar winds blowing atmospheres of planets off, which does happen if the planet doesn't have a high enough magnetic field. That's the one. Now let's just turn habitable zones off. There's a bit of a glitch in that. And here we can see a random planet. Let's just start up the simulation. Oh, isn't that beautiful? Now this planet obviously doesn't have much of an atmosphere. Let's change that. But as you can see, it's warming up from exposure to Aldebaran, which seems to be having a bit of a graphical glitch going on. How about... Now, you've also got some powers, so you've got dispense, shoot body, force, and exploder. So how about we explode a Lural? Boom. Now, Lural, have a look at that. Little fragments of Lural just flying out from the epicenter. All those pieces. You can change this. Whoa. Now that's a bit of a glitch. As you can see, they are still affected by the gravitational pull of Aldebaran. But all in all, very good. Let's start a new simulation. Here's the Earth. Beautiful, isn't she? But one of the new features is no. Quarter of an hour per second. But one of the new features, which is vastly improved since Universe Sandbox 1, okay, don't do that, that just killed the frame rate, is collisions. Now, hopefully, if future me remembers, on that future me, to show what a collision would look like in Universe Sandbox 1. Now, in Universe Sandbox 1, collisions were, as you can see, cool, but not very pretty looking. Now, here, you can see they're vastly improved. And collisions between objects heat up the planet greatly. As you can see, the surface temperature, and they gradually cool down as they do, but they deform the surface of the planet, or moon, as is the case here. and create all these chunks of fragments. So you can, which can come back and down and collide later, but you can change. As you can see, Earth has been changed by that sudden impact, and is much more barren and a much higher surface temperature. 2 times the surface temperature, in fact, I believe, roughly. 200 and something Kelvin. But as you can see, it is far more beautiful, and you can, ooh, well, look at this, recreate the, ooh, look at that, not a perfect sphere as well, but one of the possible, the theoretical origins of the moon itself, which was a Mars-sized protoplanet colliding with a young Earth, sending debris hurtling outwards, which reformed in orbit around the Earth as the moon itself. And oh my god, that looks like a Death Star. Just have a look at the craters being formed. Yeah, so that is, apart from a climate, which is a damn fine thing to put on. You can see this does actually look much beautiful, and this terrain deformation, being able to terraform planets, which is a upcoming feature, I think, or well, it is in it at the moment, but doesn't work 100% well. But remember, this is an alpha, and it is gorgeous, and I do recommend anyone who is interested in this sort of thing to get Universe Sandbox 2. It is fantastic in its alpha stage, and much more stable, I must say, than Sandbox 1. But yes, having this ability to collide planets and actually have them affect the planets with terrain deformation and messing up their atmospheres and whatnot. Oh, as you can see, the moon's just been hit again. But look at the Earth here. We got some water coming back, but due to the atmosphere, it's cooling down at a much slower rate than the moon. It's still 147 degrees Celsius. That's much higher than the temperature you need to boil water at standard atmospheric pressure. But oh, just having these sorts of collisions, it is beautiful, and you can try and recreate the formation of the moon. See if you, there's a challenge for anyone. Try and see if you can get the moon to form by colliding Mars with the Earth. Yeah, I am gushing way too much for a game like this. Anyways, I have been the Smithy99999. Wait, Smithy9999. Oh, I said 9. Too many 9s for once. Yes. This has been Universe Sandbox 2. Goodbye. To know that we are made up of the same stuff that makes up our pets, our plants, our houses, our cars, our roads, our planet, our solar system, our moon, our star, those stars, those little